1300 CE, sub-zero plains. Cree hunters must move families and meat across frozen rivers. You stand beside them, snow-biting moccasins, breath-frosting, sitting bow strings. The travelers strap rawhide snowshoes that widen their foot placement across powdered winter plains snow, preventing sinking and enabling continued movement across otherwise impassable surfaces today. The travelers use bent willow frames that determine snowshoe load distribution, because widened foot placement from rawhide snowshoes transfers body weight through curved supports in winter. The travelers experience sinew lashings freezing stiff, which stiffens snowshoe joints, because bent willow frames transmit cold through bindings during sustained sub-zero travel conditions across landscapes. The travelers depend on soft-tanned moccasin soles to grip ice on frozen river surfaces, because stiffened snowshoe joints require footing when stepping off into crossings. The travelers line moccasins with fur that trap warmth against snow-compressed ground layers, because gripping icy rivers exposes their feet to prolonged conductive cold conditions. The travelers carry elk antler awls to repair cracked snowshoe webbing, because frozen sinew lashings fracture under load during movement pauses across open plains in winter. The travelers adopt wooden toboggans instead of wheeled transport, because repaired snowshoes allow hauling supplies across packed winter snow routes without rolling resistance over long distances. The travelers shape upturned toboggan noses to reduce drag against drifted snowbanks, because hauling loads on packed routes demands minimized forward resistance during travel across plains. The travelers cover toboggan decks with rawhide to resist ice abrasion, because upturned noses still scrape frozen crust during hauling across compacted river crossings in winter. The travelers adjust drag rope length to control toboggan tracking behind pullers, because rawhide decks slide unpredictably across glazed snow surfaces without guidance on long hauls. The travelers adopt forward-leaning posture to adapt pulling under toboggan weight loads, because controlled rope tracking transfers drag forces into their shoulders and hips effectively. The travelers build birch pole frames to keep toboggans flexible, because forward-leaning posture concentrates stress where rigid sleds would crack in extreme cold weather conditions. The travelers measure frozen river ice thickness to dictate crossing routes, because flexible toboggans still fail if distributed loads exceed ice-bearing capacity during winter travel. The travelers use stone-weighted testing poles to probe river ice before steps, because thickness measurements require localized confirmation ahead of moving loads across unknown crossings. The travelers cross in single file to reduce stress fractures across river ice sheets, because sequential loading prevents sudden distributed overload from groups during winter crossings. The travelers wear bison hide cloaks that block wind at shoulders and backs exposed, because single-file crossings slow movement and increase convective heat loss rates. The travelers orient fur direction on cloaks to shed blowing snow downward from bodies, because blocked wind still drives drifting particles into exposed seams during travel. The travelers fasten bone toggles to secure cloaks without metal freezing skin, because fur-directed shedding keeps moisture from accumulating at closures during storms and blizzards. The travelers wear fur-wrapped hoods to channel breath away from faces, because bone toggles seal cloaks tightly and concentrate exhaled moisture upward during cold travel. The travelers develop ice-crusted facial hair that limits visibility while moving through snow, because redirected breath condenses and freezes along exposed beards during extended journeys. The travelers carry wood-shafted spears to maintain balance within mittened hands during hunts, because reduced visibility requires tactile reference points while advancing across snowfields slowly. The travelers use stone points that chip when striking frozen bison hide during hunts, because wood shafts transmit impact forces directly into brittle, lithic edges conditions. The travelers adjust spear throw angles for slippery snow footing during charges, because chipped stone points require precise placement to penetrate thick winter hides at distance. The travelers use group encirclement geometry to drive bison toward deep snowdrifts for capture, because precise throws succeed best when prey movement is constrained by terrain. The travelers exploit snow depth that slows bison leg movement during winter hunts periods, because constrained animals exhaust quickly when lifting heavy limbs repeatedly in drifts. The travelers cannot dig pits for mechanical traps on frozen ground during winter, because hardened soil resists tools and absorbs impact energy without displacement for capture. The travelers experience brittle wood causing deadfall traps failing in severe cold conditions, because frozen fibers lose elasticity and fracture under sudden compressive loads during hunts. The travelers replace trap building with communal driving on frozen terrain during hunts, because unreliable deadfalls demand coordinated human force to control prey movement across plains. The travelers use wind direction to guide hunter placement around bison herds on snow, because communal driving requires concealment of scent during approach across open terrain. The travelers notice condensed breath plumes, revealing positions during close pursuits in winter, because cold air turns exhalation into visible vapor against dark backgrounds on snow. The travelers endure ice-hardened snow reflecting glare into hunters' eyes during travel, because smooth crust surfaces act as mirrors under low winter sun angles conditions. The travelers wear slitted wooden goggles to reduce snow blindness during travel across plains, because reflected glare overwhelms pupils and damages retinas without shading in winter. The travelers use stone scrapers that flake when working frozen bison hides in winter, because stiffened collagen resists cutting edges and transfers stress into tools processing. The travelers perform immediate skinning to prevent hides freezing, bonded to flesh, because delayed processing allows exposed moisture to crystallize and lock epidermis to muscle during hunts. The travelers observe bison fat freezing solid before rendering fires ignite, because immediate skinning exposes lipid layers that lose heat rapidly in sub-zero camp conditions overnight. The travelers transport frozen meat slabs upright upon wooden toboggans during travel, because solidified fat stiffens carcass sections into stackable forms resisting deformation on sled decks. The travelers insert bone frames to space meat, preventing refreezing together on sled surfaces, because upright slabs still conduct cold and bond when pressed during hauling. The travelers shift camp placement onto leeward riverbanks for shelter from wind, because spaced meat loads require stationary processing without convective heat loss from exposed working hands. The travelers build snow-walled windbreaks, redirecting gusts around winter camps during storms, because leeward riverbanks alone cannot block turbulent crosswinds off frozen channels. The travelers pack snow floors to insulate bodies from underlying ice inside shelters, because windbreaks reduce airflow but conductive cold still drains heat through ground contact. The travelers choose resin-rich pine for fire starting in cold conditions, because insulated floors retain warmth only if sustained combustion replaces continuous environmental heat losses. The travelers encounter ice-coated branches snapping while gathering winter firewood near camps, because resin-rich pine limbs fracture brittly when sap freezes within woody tissues. The travelers place central fires to thaw tools and hands efficiently within camps, because brittle firewood burns unevenly and requires frequent handling to maintain ignition. The travelers notice low freezing smoke reducing visibility surrounding winter camps during nights, because central fires smolder in dense cold air trapped by snow walls. The travelers avoid night travel due ice sheen on snow causing falls, because smoke-obscured camps and reduced contrast make footing hazardous after sunset hours. The travelers experience short daylight angles limiting distance covered during winter travel periods, because night avoidance compresses movement into brief, illuminated windows between dawn and dusk. The travelers leave broken branch markers indicating rest stops along trails in snow, because shortened travel periods require reliable navigation cues during return journeys. The travelers reuse trails compacting snow easing, return journeys across plains winter, because broken branch markers concentrate traffic into established corridors, improving traction efficiency. The travelers observe frozen urine marks signaling recent human movement along travel routes, because compacted trails preserve moisture patterns longer than unconsolidated snow surfaces. The travelers experience continuous ice accumulation, forcing constant tool maintenance during winter travel, because moisture from handling freezes onto surfaces and alters tool geometries. The travelers sand ice-scarred spear shafts with stone before reuse hunts, because accumulated glaze disrupts grip stability and balance during thrusting and throwing motions. The travelers observe frozen sinew shrinking, tightening bindings around frames during overnight cold, because absorbed moisture crystallizes and contracts fibrous materials under thermal stress. The travelers pack snow into hair braids, preventing loose strands freezing during travel routes, because tightened bindings reduce dexterity needed to clear vision-obstructing ice buildup. The travelers use antler-handled knives, insulating grip from metal freezing skin contact during winter, because frozen sinew bindings force frequent tool adjustments requiring prolonged handling. The travelers build stone hearths to melt snow for water beside camp's nightly fires, because insulated grips still require hydration, as cold air dehydrates through respiration. The travelers find hide thongs stiffen, limiting knot adjustments after prolonged exposure cold, because melted snow refreezes within fibers, locking structural configurations into place. The travelers watch snowdrift walls grow taller, blocking wind as storms accumulate winter, because immobile hide thongs prevent lowering windbreak profiles during extended weather events. The travelers hear river ice groan, signaling load limits beneath crossing bodies today, because growing snowdrift walls delay departures until accumulated loads demand renewed crossings. The travelers observe toboggan runners glazing, reducing friction on sun-polished snow surfaces winter, because delayed departures allow solar crusts to harden travel corridors. The travelers find fur mittens reduce finger dexterity, affecting spear release, timing accuracy, because glazed runners increase travel speed, requiring faster reactions during encounters. The travelers experience breath-freezing eyelashes, narrowing vision during headlong pursuit across snow, because reduced dexterity prevents clearing ice while running at speed. The travelers notice hard-packed trails telegraph sound, betraying approach to bison herds winter, because narrowed vision delays detection until footsteps echo across frozen crusts. The travelers experience ice lenses forming over eyes, requiring frequent blinking during travel, because telegraphed sound forces rapid head movement through frigid air currents. The travelers hear hide lashings creak, indicating stress before structural failure under cold, because blinking interrupts monitoring while vibrations propagate through frozen bindings. The travelers observe snow load bending willow frames, altering toboggan alignment during hauling, because stressed lashings transmit uneven forces into flexible sled architectures. The travelers see frozen blood darkening snow, revealing hunt paths, afterward travel routes, because misaligned toboggans slow extraction and increase visible spoor across white surfaces. The travelers see bison lungs steam marking collapse points on white ground winter, because superheated breath condenses instantly against frigid air during terminal exertion and collapse events. The travelers perform immediate quartering to prevent carcass freezing solid overnight in winter camps, because collapse point bodies lose residual heat rapidly through exposed muscle surfaces after death. The travelers use bone wedges to pry joints apart when sinew locks frozen stiff, because delayed quartering allows connective tissues to crystallize and immobilize natural articulation points. The travelers find snow-caked cloaks gain weight, increasing fatigue during marches across plains, because extended butchering exposes garments to accumulating wind-driven moisture and ice adhesion. The travelers choose wind-scoured ridges for firmer footing than valleys during winter travel, because heavy cloaks reduce balance margins on unconsolidated snow surfaces under load. The travelers feel ice needles sting cheeks, forcing lowered head posture while moving, because ridge winds accelerate particles that impact exposed skin during forward progress across open terrain. The travelers build packed snow ramps to ease toboggan launches from camps during departures, because lowered head posture reduces visibility when initiating loaded sled movement. The travelers struggle with frozen cords resisting coiling, complicating storage on sleds in winter, because repeated ramp launches require rapid securing of trailing lines afterward. The travelers maintain sled spacing, preventing collisions on descents over ice sheets. Winter, because uncoiled frozen cords limit braking adjustments during downhill movement on glazed surfaces. The travelers adopt angled travel paths towards sun-low winter dew snow glare, because collision avoidance requires visual clarity when descending reflective ice sheets. The travelers use two-hand grips on ice-slick hides during hauling across snow routes, because angled paths reduce leverage and require symmetrical force application for control. The travelers misjudge steps on crusted drifts, do cold-numbed feet during travel winter, because two-hand hauling occupies balance corrections normally handled through foot placement feedback. The travelers synchronize breath timing with throws to avoid fogged vision in winter, because numb feet destabilize stance, requiring precise visual targeting during weapon release. The travelers deliberately blink to shed ice from snow-laden eyelashes during Hunt's winter, because synchronized breathing still condenses moisture onto lashes during exertion. The travelers find frozen ground amplifies footfalls, altering stalking approach near bison herds, because blinking interruptions reduce awareness of sound propagation across hardened surfaces. The travelers use wind-packed snow, supporting weight, enabling faster approaches during winter hunts, because amplified footfalls necessitate surfaces that absorb sound through compaction and cohesion. The travelers follow ice seams, guiding river crossings between pressure ridges in winter, because faster approaches lead to rivers where load-bearing zones must be visually identified. The travelers experience cold, swollen joints, slowing reaction during sudden bison turns on snow, because river crossings stiffen limbs through prolonged exposure to conductive ice. The travelers suffer snow-choked nostrils, limiting breathing pace while running across plains winter, because slow joint reactions force longer pursuits, increasing inhalation of airborne crystals. The travelers endure hide straps abrading shoulders under constant toboggan pull during travel, because constrained breathing posture concentrates load pressure into limited contact zones. The travelers warm frozen knots with teeth before loosening during winter camps, because abraded shoulders require frequent pack adjustments that stiffened bindings prevent. The travelers observe snow density changes dictating pathfinding across open flats during travel, because delayed pack access disrupts load balance, requiring terrain-based compensation strategies. The travelers dull blades faster on ice-polished stones during processing of bison winter, because altered pathfinding increases tool-ground contact while working frozen carcasses. The travelers see fur seams crack when flexed too rapidly in extreme cold, because dulled blades demand greater force, causing structural stress on garments during cutting motions. The travelers recognize snow berms marking previous camps, guiding return, routes across plains, because cracked garments require revisiting sheltered locations for repairs and rest. The travelers experience frozen river mist coating clothing, adding weight during crossings winter, because return routes follow river corridors where spray freezes instantly on fabric surfaces. The travelers adjust hoods against wind-driven ice scouring faces during travel winter, because mist-coated clothing stiffens and redirects airflow toward exposed facial areas. The travelers encounter snow-bridged creeks, concealing breaks threatening ankle injuries during travel winter, because hood adjustments narrow peripheral vision while navigating complex terrain. The travelers struggle with ice-cemented packs resisting opening, delaying meat access at camps winter, because ankle injuries slow camp setup and increase exposure duration. The travelers observe cold-flattened sinew losing elasticity, affecting binding strength during winter travel, because prolonged pack exposure freezes fibers into rigid, load-inefficient forms. The travelers face snowfall, erasing tracks, forcing continual route re-establishment during winter travel, because weakened bindings require careful navigation to avoid equipment failure under load. The travelers experience ice-edged hides cutting mittens during handling of bison winter hunts, because re-established routes still involve processing frozen carcasses with dulled edges. The travelers crack frozen marrow with stone before extraction during winter camps, because mitten damage exposes fingers, requiring indirect methods to access nutritional resources safely. The travelers shift snow-packed camps daily following bison movement across plains winter, because marrow extraction and meat processing necessitate proximity to migrating herds. Across frozen plains, forest margins, and lake ice, native tribes hunted and traveled in winter by converting terrain resistance into movement systems. Snow depth controlled footwear width, ice thickness, governed routes. Fat content of animals determined hunt timing. Each tool shape, travel rhythm, and camp placement emerge from winter, acting on muscle, bone, wood, hide, and daylight. These tribes did not confront cold abstractly. They solved measurable constraints through material design and seasonal logistics. Hunting methods adjusted to winter acoustics and visibility. Game moved through compressed corridors where snow depth restricted turning angles. Hunters followed hoof and paw impressions, using wind direction and surface hardness to shorten pursuit distance. Travel systems reduced energy loss by distributing body weight across snowshoes and sled runners. Camps shifted toward timber edges where wind exposure dropped and fuel density increased. Every movement cycle balanced distance, drag, food yield, and remaining light under conditions that punished inefficiency immediately. These adaptations formed interlocking systems rather than isolated techniques. Transport capacity defined hunting radius. Hunting yield governed camp spacing. Camp placement regulated repair intervals and fuel access. Winter forced these variables into tighter tolerances, compressing decision margins and magnifying error. Over generations, native tribes refined these constraints into repeatable patterns that converted frozen landscapes into navigable infrastructure. Within the broader human record, winter subsistence systems show environmental pressure shaping social organization through material engineering. Success depended on precision in route choice, load geometry, insulation thickness, and caloric sequencing. These tribes assembled winter environments into usable systems. By late season, trails hardened into ice corridors, camps compacted into thermal basins, and hunting routes aligned with migrating herds and frozen waterways. The cold remained unchanged. Human movement alone shifted. When spring melt erased these systems, compressed snowpaths, emptied kill sites, and repaired tools remained until winter returned again.